This is a question from theory of computation. Given the language L is equal to a to the power 2m, c to the power 4n, d to the power n, and b to the power m, and m comma n greater than or equal to 0, find the best appropriate match to recognize L. We have finite automata, push-down automata, non-deterministic Turing machine, non-deterministic push-down automata. So from the language, we can understand that it is accepting 2 times m. The number of a's will be 2 times m. The number of c's will be 4 times n. Number of d's will be n times, and number of b's will be m times, and m comma n greater than or equal to 0. So from this itself we can understand that there is a sort of comparison that has to be made while accepting this, because this n should be mapping with 4 times the n, and number of b's should be half of number of a's. So there we are having a comparison involved. We have to compare these two and we have to compare these two. Since there is a comparison involved, we cannot use finite automata as it requires memory. So finite automata is directly not the correct answer. Next, the possible solution can be push-down automata, non-deterministic Turing machine, or non-deterministic PDA. So from this, we can see that a single stack can be used to solve this above question. Let's see how to solve it. We'll push as many number of a's that comes in. So it will be coming in 2 times the number of m. So we'll push as many number of a's. Then we will push as many number of c's as it comes. Now what happens is this pattern gets stored in the stack. Now when d comes, for 1d we will pop 4 c's. So for 1d we will pop 4 c's. So this gets done. This gets repeated for how many d's that we are seeing. Then for 1b we pop 2 a's. So for 1b we pop 2 a's. For another b we pop 2 a's. So in the end, if the stack is empty upon performing this operation, so that is for 1d 4c is popped, and for 1b 2 a's are popped. And by doing this, if the stack is empty, we can say that the language L is accepted. And if the stack is not empty, then we can say that this string does not belong to the language L. This can be done using a deterministic pushdown automata, as well as a non-deterministic Turing machine, as well as a non-deterministic PDA. But we have to go for the tightest bound, so it will be accepted by pushdown automata. The correct answer here will be option B, pushdown automata, even though it can be accepted by all the three. We go for the tightest one, so option B, pushdown automata is the correct answer here.